Okay, so you know how advanced AI is just, well, everywhere now.
Yeah.
In our work, our lives, it feels like it's accelerating.
It really does, and keeping up can feel like a full-time job in itself.
Exactly. So today, we want to help you get a handle on something specific, but really important. Artificial Capable Intelligence, or ACI.
Right, this isn't just narrow AI doing one tiny task, but it's not quite the sci-fi general intelligence either. It's something potent in between.
Precisely. And the key question is, how do we know if these powerful ACI systems are actually built well? How are they evaluated?
Uh-huh. That's where the source material for this deep dive comes in.
Yet we're looking at a document called A Methodology for Evaluating Artificial Capable Intelligence, ACI Architectures,
Yeah.
Platform-Agnostic. It's from publisher name, redacted for brevity, as per instructions,
Hmm.
and it's slated for release around May 2025.
And our goal here is basically to pull out the core ideas for you.
Right, give you that shortcut understanding of how the architecture, the underlying design of these systems gets assessed. No need to wade through the whole dense document yourself. Sound good?
Let's do it. It's fascinating stuff because as AI gets more capable, the blueprint underneath really, really matters.
Totally. It's not just, does it work?
Yeah.
But how is it built? Is it solid? Is it responsible?
Exactly. And this methodology gives us that framework. It starts by, drawing some lines in the sand, defining terms.
It's the classic ACI versus ANI versus AGI distinction. It's important to get everyone on the same page.
Definitely. So ANI, artificial narrow intelligence, that's the AI we've had for years. Good at one thing, like, I don't know, spam filtering or recommending a movie.
Your basic single-task AI.
Right. Then you've got AGI, artificial general intelligence. That's the hypothetical future AI, human-level smarts across basically everything. Still theoretical.
So firmly in the maybe someday category.
ACI, artificial capable intelligence, is where the action is now and where this methodology focuses. It's AI that handles complex, goal-driven tasks, but within a specific field or domain.
So super capable, but not universally capable. I think Mustafa Suleiman's concept really helps here, framing ACI around delivering practical results in a defined area.
Absolutely. He really crystallized that idea. The methodology uses a great example, healthcare.
Oh yeah, that was helpful. And ACI could be brilliant at analyzing, say, oncology reports, radiology scans, and genetic data together.
Right, integrating all that to provide really deep insights for doctors within that specific medical domain.
But, and this is the key, it wouldn't suddenly know how to, like, trade stocks or manage logistics. It stays in its lane, domain-wise.
Precisely. The focus is practical capability, tangible value within boundaries. And that's what this evaluation method is built to assess, not theoretical AGI potential.
Okay, that makes a lot of sense. So
Yeah.
if that's what ACI is, what are the bedrock ideas, the core principles that the methodology says should guide how these systems are architected?
Good question. It lays out 5 fundamental principles. They're sort of the North Star for designing and evaluating these architectures.
Okay, lay them on me. What's number one?
First up is capability-centric. Simple idea, really. Every single piece of the architecture needs to directly contribute to what the ACI is supposed to do. Its functions, its goals.
No wasted motion. Everything pulls its weight towards the objective. Got it. What's next?
Second is pragmatism and domain specificity. Basically, the architecture has to work in the real world in its specific context. Forget purely theoretical elegance if it's not practical for that domain.
Right, so an ACI designed for, I don't know, underwater exploration needs an architecture that accounts for the realities of that environment, not just abstract perfection.
Exactly. Third principle, data as fuel. This is huge in AI, obviously. The architecture must be designed to handle data well, ensuring quality, relevance, security, accessibility, proper governance. Data is the lifeblood.
You can't run a high-performance engine on dirty fuel. Makes total sense.
Okay.
2 more.
Fourth is integration first. This one's critical. ACIs almost never live in a vacuum. They need to connect smoothly with existing enterprise systems, other tools, data sources. Integration can't be an afterthought.
Yeah, I can see that. A super smart AI silo isn't much help if it can't share information or receive inputs easily.
Precisely. And the fifth, arguably the most crucial these days, is responsibility by design.
Ah, okay. So ethics, security, fairness, privacy, all that baked in from the start.
Exactly, not bolted on later. These concerns must be fundamental architectural considerations right from the blueprint stage.
Okay, so those 5, capability-centric, pragmatism and domain specificity, data as fuel, integration first, and responsibility by design, They're the guiding philosophy.
That's the foundation. And understanding those principles really shows why we need a dedicated evaluation methodology like this one.
Right, because these ACI systems are complex beasts.
Yeah.
And the consequences, if they're poorly designed, well, they can be pretty significant financially, reputationally.
Societally, even. Think about AI and critical infrastructure, finance, healthcare. The stakes are incredibly high.
So this methodology isn't just a checklist. It's about ensuring the architecture genuinely supports those 5 core principles.
Precisely. It provides a structured way to look under the hood and ask, does this design actually enable the ACI to deliver its capabilities effectively, reliably, and crucially, responsibly?
It's digging deeper than just looking at the outputs. It's about the how
Yeah.
at a fundamental level.
Yes. And the methodology highlights 4 key requirements that the evaluation needs to verify the architecture can meet.
Okay, what are those big requirements?
First, data integrity. Is the data foundation solid? Is the data handled properly? Second, seamless integration. Can the system actually connect and play well with others?
Right.
Third, responsible AI. Are those ethical and safety considerations truly built in? And fourth, capability enablement. Does the architecture actually support the needed functions, the performance, the scaling, the maintenance to achieve the goals?
Wow. Okay, so it covers the whole life cycle in context. Data, connections, ethics, and actual performance. That's comprehensive.
It has to be.
So let's dive into the first dimension the methodology uses for evaluation: data integrity and governance architecture. This seems to connect directly back to that data is fuel principle.
Absolutely. And responsibility by design, too, because it covers the ethical and secure handling of data. This dimension assesses how the architecture ensures data quality, enforces governance rules, and makes sure data flows efficiently and securely.
Okay, breaking that down, what specifically are they looking at for data quality management within the architecture?
They're checking if the architecture supports things like strong data validation routines. How does it handle data cleansing? Is there good data lineage tracking, knowing where the data came from and what's happened to it?
So you can trust the data's history.
Exactly. And how does it cope with different data types? Structured, unstructured data. How does it integrate data quality checks into the whole machine learning lifecycle? Is there automation for things like anomaly detection in the data?
So it's building quality assurance right into the data pipelines, making it continuous.
That's the idea. Then there's data governance enforcement. This is about the rules.
Access controls, policies, that sort of thing.
Right. How does the architecture actually enforce policies around data usage, access rights, privacy regulations like GDPR or CCPA, data retention schedules? Does it support roles like data stewards effectively?
And how does it fit into the bigger picture, like enterprise data frameworks?
Good point. They look at integration with things like DAMA DMBOA, TOGAF, DSAM, these broader governance structures. And crucially, does it provide clear audit trails? Traceability is key for governance.
You need to be able to see who did what when with the data. And the third part of this data dimension, data accessibility and flow.
Yeah, this is about movement. How efficiently and securely does data get to the ACI models, and how do insights get out? Are the data pipelines robust? Can they scale?
Does it support the whole life cycle? Ingestion, storage, processing, versioning.
All of that. Plus, if real-time data is needed, how well does the architecture support streaming? And importantly, does it help break down data silos across the organization, ensuring consistency?
It's clear data isn't just passive stuff you pour in. The whole data ecosystem needs careful architectural design. Okay, dimension 2. Seamless integration architecture. This maps to integration first, right?
Directly, it's all about connectivity. How well does the ACI system talk to other components, both internally and within the wider company tech landscape?
Makes sense. So what are the main criteria here? What do they evaluate?
A big one is API strategy. APIs, application programming interfaces, are like the doors and windows between software systems.
The way they communicate.
Exactly. So the evaluation looks at the design of these APIs. Are they robust, secure? How are different versions managed? Are they easy for developers to find and understand? Is the documentation clear?
A good API strategy sounds like the essential connective tissue.
It really is. It enables that modularity and smooth interaction. Next, under integration, is system interoperability.
Okay, so this is about the actual tech used for connecting things.
Pretty much. Things like middleware, message queues, standardized connectors, the tools that bridge the ACI to existing systems. They assess how easy it is to plug the ACI into the current environment. Does it use common standards like REST or JSON?
And can it handle complex setups, like hybrid cloud and on-premise systems talking to each other.
Yes, that flexibility is important. How well does it navigate the messy reality of enterprise IT?
Okay. And the third piece of the integration puzzle.
Workflow orchestration. This is becoming huge. It's about coordinating sequences of tasks that might involve the ACI, other software, maybe even human steps, all as part of a larger business process.
So managing the flow of work across different systems.
Exactly. The evaluation looks at how the architecture supports this. Does it use specialized workflow engines like Airflow or Tecton? How does it manage the state of these long-running processes? Is the orchestration approach modular, scalable, performant?
And can it link up with, say, business process automation tools or even manage teams of AI agents working together?
That's becoming increasingly relevant, yes. Evaluating that capability to coordinate complex, multi-step, multi-actor workflows.
Integration is clearly much more than just simple connections. Okay, dimension 3. Responsible AI architecture. This feels absolutely critical.
Paramount. It embodies that responsibility by design principle we talked about. It draws on established frameworks like the NIST AI Risk Management Framework, ISO standards.
So it's about baking in trust, safety, ethics, compliance from the get-go.
That's the core idea. It's not an add-on, it's part of the architectural DNA.
Let's break it down using those trustworthy characteristics. What about security and resilience?
Okay, so here they're assessing architectural safeguards. How does it protect the models, the data, the infrastructure itself from attacks? Are secure coding practices embedded? How are vulnerabilities managed?
Beyond standard cybersecurity, what about AI-specific threats?
Great point. They look at robustness against unexpected inputs, resilience against failures, and defenses against things like prompt injection.
Where someone tries to trick the AI with clever prompts.
Exactly. Or data poisoning, feeding it bad data to mess up its learning. Or model evasion attacks. The architecture needs defenses against those.
Okay. What about privacy?
Here, it's about architectural support for privacy-enhancing technologies, PETs. Does it help comply with regulations like GDPR? Does it follow privacy by design principles? How is personal data handled securely? Can it support user data rights requests?
Built-in privacy features. Then fairness and bias mitigation. How does architecture play a role there?
It's about enabling detection and correction. Does the architecture allow for monitoring models to find bias? Does it support interventions, like making it easier to retrain models with better data if bias is found? Does it facilitate using diverse data sets?
So providing the technical means to address fairness issues, what about transparency and explainability? People want to know why an AI made a decision.
Right. So does the architecture support good logging, audit trails? Can it integrate tools that generate explanations, things like SHA or Lime where appropriate? Is there clear documentation on capabilities and limitations? Alignment with transparency standards.
Giving visibility into the black box as much as possible. And accountability and governance.
This looks for architectural features that enable human oversight. Are there clear points for human review or intervention? Does the architecture help enforce roles and responsibilities? Does it align with the organization's overall AI governance policies?
Making sure there are controls and humans in the loop where needed. Finally, within responsible AI, safety and compliance readiness.
Safety focuses on things like fail-safe mechanisms. Can the system degrade gracefully? Are there reliable ways for operators to shut it down safely? Does it align with relevant safety standards, like IE 7010?
Got it. And compliance readiness.
That's about how the architecture makes it easier to adhere to regulations, like the EU AI Act. Does it help generate the evidence needed for audits and compliance checks?
Wow. That's a deep dive just on the responsible AI aspects. It really shows how interconnected all these facets are. Security, privacy, fairness, transparency, safety. They all rely on the underlying architecture.
They absolutely do. You can't achieve them effectively without architectural support.
Okay, let's move to the final dimension. Capability, enablement, and value realization. This brings it back home, right? Does the tech actually deliver?
Exactly. This connects all the technical stuff back to the practical purpose. It links to capability-centric and pragmatism and domain specificity. Does the architecture actually enable the ACI to do its job and provide value?
So what's evaluated here? First criteria.
Goal alignment. How well does the architectural design directly support the business objectives? Does it enable the specific tasks the ACI needs to perform? Does it consider the end users, the UI/UX aspects?
Is the tech actually fit for purpose? Does it help people and the business?
That's the essence. Then performance and scalability. This is crucial.
Speed, throughput, handling load.
Right. Can the architecture inherently meet the performance targets? What patterns are used for scalability, things like microservices, load balancing to handle growth? And is it efficient with resources, using compute power wisely?
You need it to be fast and handle growth, but not cost the earth to run.
Precisely. And the last piece here is reliability and maintainability.
Keeping it running smoothly and being able to update it.
Yes. Does the architecture support fault tolerance? Good monitoring and observability, knowing what's happening inside. For machine learning systems, how well does it support MLOps practices?
MLOps. So things like automated testing, version control for models, CI/CD pipelines for smooth deployments, monitoring in production.
All of that. Does the architecture make MLOps easier? And finally, does the architecture itself promote maintainability? Is it modular, well documented, easy to understand and modify over time?
It sounds like a balancing act, building something powerful, but also stable, efficient, and manageable long term.
It always is in architecture. There are trade-offs. This dimension assesses how well those trade-offs support the ultimate capability goals.
Okay, that covers the four main evaluation dimensions. The methodology also looks at the broader industry landscape, right? What are the big players doing?
Yeah, it acknowledges that you need to look at trends. Observing leading organizations, Google DeepMind, Microsoft, OpenAI, Anthropic, the Frontier Model Forum they've formed,
What architectural themes are emerging from these leaders?
several key ones. A huge push towards advanced reasoning and problem solving, making AI think more deeply.
Hmm.
Multimodality is another big one. Systems that fluidly handle text, images, audio code, etc. all together.
Processing richer, more diverse information.
Exactly. Also, agentic capabilities and autonomy. AI agents that can plan, take actions, pursue goals more independently.
That sounds like a significant step up in capability.
It is. And it has big architectural implications.
So how do these trends impact the evaluation we've been discussing?
Well, for advanced reasoning, you need to assess architectural support for complex computation, knowledge representation. For multimodality, evaluate the flexibility for handling diverse data formats efficiently.
And for those agentic capabilities?
You really need to scrutinize the support for agent frameworks, how multiple agents are orchestrated, and critically, the mechanisms for human oversight and control. That becomes even more important.
That makes sense. Any other trends?
Integration and workflow enhancement remains vital, perhaps even more so as systems get more complex. And scalability and efficiency are constantly under pressure with larger models, maybe even touching on environmental impact of compute resources.
Right.
And underpinning all of this, safety, ethics, and responsibility become non-negotiable. That responsible AI architecture dimension we discussed, its importance just keeps growing as capabilities increase.
It's fascinating. The cutting edge reinforces the need for these foundational evaluation principles. It's not just about making AI smarter, but making it smarter and safer and more reliable and more integrated.
Absolutely. You need that structured, principled approach to assessment more than ever.
Okay, so let's try and wrap this up. If you had to summarize the key takeaways from this deep dive into evaluating ACI architectures.
I'd say the main thing is understanding that a dedicated methodology is crucial. Evaluating these advanced ACI systems requires looking holistically at the architecture, the blueprint.
Not just the algorithm in isolation.
Right. You need to assess how well that blueprint handles data, how it integrates, how responsibility is embedded, and ultimately how it enables the intended capabilities reliably and effectively. It's a multifaceted challenge.
And hopefully, walking through these dimensions, data integrity, seamless integration, responsible AI, and capability enablement has given you, the listener, a clearer map for navigating this complex territory. A shortcut, like we aimed for.
Definitely. And it leaves us with a thought, perhaps. As you encounter or use AI, increasingly capable AI in your own world, maybe start thinking about it through these lenses.
How is the data being handled? How well does it connect? Are there signs of responsibility being designed in?
Exactly. How is that balance being struck between pushing the boundaries of capability and ensuring these powerful systems are built on a foundation of trust and responsibility?
That's a great point to ponder, something for all of us to keep in mind as AI continues to evolve.
Indeed.
Well, thanks for unpacking that methodology with me. And for everyone listening, if this sparked more questions or you want to explore further, please do reach out. We're always learning too, and happy to continue the conversation.